Thanks, Miss Bauckham.
Okay,
Who's that?
so inequalities. Inequalities meaning n equal, not equal, meaning you can compare with a greater or a less than symbol. Like we just did with our triangle inequality theorem. You're checking two sides have to be greater than the third side. The exterior angle inequality happens because of the exterior angle theorem. So on your green paper, please take a minute and at angle X, put 100 degrees in that angle. And put 60 degrees at angle Y. And then I want to see if you guys remember the exterior angle theorem.
It's got to be 80. Z equals 80.
Okay, so Z plus Y, the remote interior's sum has to make the same total as X. So if Y is 60, then Z has to be 40.
Wait,
Yes.
but I thought X would be 40.
No,
would
the
be 80.
exterior angle is the sum of those two. So where's 80? 80 is right here. It's the supplementary
I mixed
angle.
the two up.
Okay. All right, so remembering the the exterior angle theorem, then the inequality should make sense. I can compare angle X to angle Y and always know that angle X is going to be bigger than angle Y because angle X is an exterior angle where that is a remote interior and that's only one of the two that add to make that whole. And then the same thing, angle X will always be greater than angle Z because this is an exterior angle and those two together have to make this angle. By the numbers that I have here, X is also larger than this angle, but we don't necessarily know that unless we have numbers, okay? So the only comparison I can make without numbers is that the exterior angle is larger than the two remote interior angles, all right? Because this could be an 80 where this is 100, so I can't compare these two. All right, next is angle side relationships, and in order to kind of think through that, I want to use this picture, or this triangle right here. So think about the orange and blue side lengths that I have for this triangle. The closer I bring that angle together, the smaller this third side would be. But in order to fit this red side, what has to happen to that angle between the orange and the blue?
It has to be increased.
It had to be pretty big, right? So in this triangle, which angle is obviously the largest angle between the blue and the orange, the red and the orange, or the red
Blue
and
and
blue?
orange.
Okay, obviously the largest angle, but notice the largest angle is always going to be across from the largest side because the angle has to open up the biggest to fit that largest side in it. Likewise, the smallest angle is always going to be across from the smallest side because the angle does not have to open up very much to fit that distance between it. Okay, so that's what these two theorems are saying. It says if one side of a triangle is longer than another side of the triangle, then the angle opposite the longer one is the largest angle. Paraphrased. Okay, so please call these angles X and Y and Z for me. And I want to order them from smallest to largest. Okay, now order the angles, not the sides. Even though all I'm giving you is the sides. I can't find the angles, I'm just giving you the side lengths. So the smallest angle I know has to be across from the shortest side, right? Because it had to open the least. So 7 is the shortest side. What is the smallest angle?
X.
X. You'll see that? So the smallest angle is angle X. And then there's the medium size and the large one. So let's look at the large one. The largest side, Tyson is, and the largest side is how long?
Well,
Which angle is across from that had to open up to that side?
why?
Y. So that is my largest angle.
No, Kyle.
And then Holly, the medium-sized angle would be
No, why?
in between the 7 and the 12 side length. It'd be across from the 9, which is angle Z.
Who,
All right,
where,
guys.
why, how? What, when, where, why, how?
All right.
Wait,
so
wait.
We
Okay.
can classify small to large to small, but we can tell which
What was that
angle's
show? It
biggest.
was on, I think, like PBS or something, and it was like there were these two cat brothers and sisters, and they solved mysteries, and then there was this song, and they were like, time to ask these questions to find out the answers. Who, what, when, where, why, how. Who, what, when, where, why, how. No, and then there was this like squiggly boy, and then it was the mayor of the town was an old cat. He was like,
Squiggly boy.
wait, it was like
I don't know still, I didn't see that.
something
But
town
we are
mystery.
videoing, can we get back to
Wait,
it?
can I look it up on Kyle's phone
No, not right now,
after class?
maybe so. Okay, let's look at our examples of how we would use those things, all right? Kyle, put that away.
Wait, something town mysteries.
Put it away for now. Okay, I'm not gonna have you draw these, but I want you to think with me. Is there a way that I can compare angle 2 to angle 3? And when I say compare, I mean greater, less, equal
Yes.
than.
They're the opposite.
Okay, true. But my two lines that create that alternate interior are not parallel lines, so I can't compare them as far as equal. But think of it in terms of one of those two ways we just looked at.
Oh, like the angle. Okay, so if which angle's bigger? So then
Oh,
that
it's-
would.
Angle 3 or angle 1 plus angle 2 equals angle 3.
So angle 3 is an exterior
Hey, what was-
angle
what-
for this
Just
triangle.
imagine that that side up there just doesn't matter, and then so imagine you don't know 6, and so you would use. 3
So
to find
you're
6.
forgetting
Oh.
that line right now, but angle 3 is an exterior angle to this triangle, and 1 plus 2 must equal 3. So out of 2 and 3, which is bigger?
Angle 3.
Angle 3. So I would make my inequality sign this way. Okay, good job. Next, 4 and 6. Can we compare them?
Yes.
Angle 6
Oh, you
is
do the
an
same
exterior
But reverse.
Same thing, but reverse. So this time, and you're really having to look carefully, angle 4 is inside of this triangle, where angle 6 is an exterior angle. So this is exterior, which means it has to equal the sum of
5 and 3.
5 and 4. So which one is bigger?
6.
Angle 6 is greater. Okay, so you see, even though there's two different triangles there, there's still one angle that was an exterior angle to this triangle. Okay, that's using the exterior angle theorem. Let's look down here. I think this one is kind of irrelevant because of the numbers that are there. X, Y, and Y, and XW. We can tell which one's bigger by the numbers. I think I did that one backwards, but I don't know how to fix it right now, so never mind. I think we can tell that one. All right, looking here. Oh, they gave us no angles, they gave us no sides. All right, what can we do, guys? They want us to find the Y and then figure out the sides from largest to smallest. Actually, I want you to draw this one in your triangles. So let's call this triangle MNP. Please draw. In order to name the sides from largest, big, medium, small, to smallest, sides in terms of MPPN, and M, I'm going to have to not just go by the looks, I'm going to have to find the numbers that are involved here. So, oh, you know what?
P is the biggest
If
angle.
you add them all together, it equals 180.
Oh, true. And I'm going to adjust because I want my number to not be a decimal. So I'm going to make angle M 2y plus 12.
Angle P is the biggest. Angle N
Angle
is the
P is
biggest.
y minus 8.
And angle N is the smallest.
And then N is what? Y plus 12. So you'll level those. Okay, but that looks like it in size. We don't know that until we find what the value of y is.
4y plus 16 equals 180.
Okay, good. So like Holly said, they're going to be total 180. Kyle's added for me. How many y's again, Kyle?
4y plus 16 equals 180.
Because I changed them.
Minus 16 equals 164. And then if you divide that by 4, then you get 41.
Okay, 41's not my degree though.
It's
Help me.
y.
Wait, hang on. Kyle, what is the degree of this angle?
41 minus 8.
Which totals?
35.
33.
Close. 33 degrees for angle P.
Watch out for correct.
Okay. Holly, can you find this one for me?
53.
That's just why.
It's just a y. Y plus 41 plus 12.
53.
Okay. And Scott, with this one?
2y plus 12. So 82 plus 12 equals 96.
So by the looks of the angles, it's deceiving. We have our measurements now.
It's just incorrect.
That doesn't equal.
Wait, it's
180.
94.
Oh, okay. 84. Oh yeah. No. 82 plus 12. 94. Okay. There we
That's
go.
what she just said.
All right. So how am I going to get the side lengths from big to small?
Because you can
Oh, it's
find the thing and
across.
then the middle opposite.
Okay, so across from the biggest angle should be the largest side. So Holly, which is the largest side?
My mouth and brain are very good at their
Angle
jobs.
or side PN.
My mouse.
Across from the biggest angle creates the largest side length. Tyson, what's the medium-sized side?
The one across from you.
Okay, so it won't have the letter M in it. It will be
MP.
NP. Good.
Or like
And
Kim
then
P
Kyle,
from Scott
the
Pilgrim.
smallest side will be N.
LOP.
And so the picture is deceiving, but that's how we found our distance.
W, X, Y, and Z. Now
Okay.
I know my
But shouldn't T be the biggest line?
Next time we'll choose one.
It looks like it, but not by the numbers. So don't go by the looks, go by the numbers.
Sometimes drawings are not to scale.
Yes,
But it
drawings
should-
not to scale.
It should
Drawings
tell you when it's not to scale.
go by the marks, not the drawings. Okay, last thing right here, and I'm not gonna have you draw it. I just want you to think with me. Can we compare side BC to side CE?
Yes.
BCCE. If they are in the same triangle, we should be able to compare them. So BC here to CE here, across from the 40 and across from the, don't know. How can I find that
It's a
angle?
40. Literally just add the two and then find the difference.
Okay, so subtracting from 180, 140 from 180 gives me a,
60s.
Kyle,
100 minus 40?
180 minus
140
That's an 80?
from 180.
140 from 180.
Wait, why is that 180 then?
Because that's the total of the angles and triangles.
Okay. I thought
Okay.
it was 40 plus.
Is everybody with me on that 40?
Oh, yeah. I
Okay,
don't
in this triangle, Kyle, how many degrees?
Oh.
In that
okay.
triangle.
Yeah, I understand that. Yeah.
Okay, not the whole angle, but just this triangle. So now, looking across from the 40, oh, what's the relationship between BC and CE?
One is from the before Christ and one is the common era.
In this triangle.
Wait and see.
They're both across from 40. What does that mean in the same triangle?
They are the equal.
They are. If they are across from the same degree angle, they are equal in degree. That's an isosceles. Remember, two equal angles creates two equal sides. Even though the looks are not there, you follow the numbers. Okay, can we compare ED and CD?
Yes. D. The angle D is 75,
75?
and then you subtract,
Oh, really?
and then you get and then you
So,
did that. So then you
across
just
from
find the
CD.
opposite.
Yeah, double check that. Across from C.
So it's bigger.
Which one's bigger?
That one.
ED or CD?
CE is the largest side.
CE is, but they want us to compare ED and CD.
CD. CD's bigger.
CD is bigger, it's across from the 55 instead of the 50. Okay? Now, what about AB and AC? Let me take some of that
That's
back off.
BC.
Oh, AB
Before Christ.
and
After.
BC.
And no BBD.
Are those in the same triangle?
After.
AB,
Wait, so what
BC.
does Anno Divini translate to?
Okay, we're still doing geometry. AB and BC. Can we compare these two side lengths?
No.
This is 40. This is, I think,
Yes.
40 also. But they're in different triangles. Do we know if they're the same length?
Whoa.
No, this is-
That's across from here, that's across from here. Can I compare them?
They're both.
No.
No,
No.
they're not from the same triangle, so that different answers.
So
different.
I cannot compare. The
If
only
he's
thing I
ultra-
could do is look across from the 100
The
is my
ultimate-
biggest side. So if that's the biggest side,
Then you can find the
that's
other
the
one.
biggest side. I still can't compare because I don't have enough information.
Right.
Okay. All right. So that's kind of our goals for today, and our assignments will be coming soon.
Get it.